All right, we've been working on a long proof, and we are really more than halfway through it right now. We've done a little bit of work. We've been thinking about what these facts are and how they tie together, and we've almost got we've almost got all of the flesh on our proof right now. Let's see what we can do to fill in the last gap there. And this is going to be kind of our step from getting 2 points on this proof to getting 4 points. The reason I'm skipping over 3 points is 3 points is if you have a whole proof, but one of your reasons wasn't quite right, or one of your statements wasn't stated quite correctly. So those are just the tiny little goofs that you can find along the way. And hopefully you're good at checking your work and stamping out those little spot fires. But let's pretend for the moment that we can fill out the rest of this proof without making any mistakes. So the idea is that we figured out how to get from this triangle congruency to the conclusion of the proof that the midpoint bisects both of the diagonals. So all we need to do is to get from our givens to the fact that these two triangles are congruent to each other. And we've already seen that we've seen one side here, but we need to know two other parts. And it's not going to be the sides because we are figuring out the sides as a conclusion. So we know that we're not going to be able to figure this out until we've got the triangle congruence at our disposal. So we need to figure out how to make some angles be congruent here. And there are two different ways we can do that. Can you see what they are based on what we know about this proof at this point? I'll give you some hints for it. One of the reasons is going to be because of the given statement we haven't used yet. So that's an important clue when you're looking at proofs, is that they don't give you any given statement, or they don't make any extra markings on a diagram just to give you kind of false leads to follow. Every piece of information they give you in a proof is there for a reason. You're going to use everything. And the other reason is going to be something that is true about angles in this diagram, whether we had that given statement or not. Okay, so the given statement we haven't used yet is that top line and bottom line are parallel to each other. And whenever you have a top line and a bottom line, when you've got two lines that are parallel to each other and you're trying to do a triangle proof, my advice to you is to always look for that mark of Zorro inside that diagram that is going to involve this side and this side. So can you see how to make a Z or how to make a backward Z from this diagram? By adding one extra line? Well, what if we add this line right there? There's a Z right there. And so that Z means that the two angles that are formed by those three lines have to be congruent to each other. And so that's this angle here and this angle here. So let's be sure that we carefully name those angles. I know this is going to be line 3. So I'm going to call this top angle. It goes from C to D to E. C, D, E. And that is congruent to this bottom angle, which I will call BAE. I've seen some people calling this the Mark of Zorro theorem, and I like that. I will be sure to let the rest of the math department know that sometimes we call it that, so that I'm pretty sure they're going to know exactly what you're talking about. The actual name is that these are alternate interior angles. And once again, when I use vocabulary, I like describing where the words come from. So We've got that transversal. These two angles are on the opposite sides of that transversal, so that makes them alternate. They're alternating between the two sides of the transversal, and they're both inside the two parallel lines. So that makes them alternate and interior angles. Okay, so that's cool. That's another piece of evidence that we have. And what is a final congruence that we can use? Well, it turns out there's a couple. If I had drawn this backward Z with this diagonal here, I could have, these are also alternate interior angles. This angle here, where C is the vertex, and this one here where B is the vertex. You could have done that, but I'm going to look at these two angles right here. So what's the relationship between those two angles? This is a vocabulary word we used from earlier in the year. So these are two straight lines that are intersecting each other, and we're thinking about angles that are on the opposite sides of that common vertex. And so those always have to be congruent to each other. So I'm going to say CED is congruent to angle, I've forgotten the angle there. CED is congruent to angle BEA. And again, if you don't remember the name of that relationship between angles, that might be a 3-point proof right there. But the reason for that, those are called vertical angles because they only share a vertex. All right, so now we've got 3 congruence statements in the top of our proof. We've got this side, we've got this angle, we've got this angle. That's enough evidence to do our congruence. So that's enough evidence to say that the top triangle is congruent to the bottom triangle. So what's our reason for that going to be? Whenever we prove triangle congruence, we have to use one of those 3-letter theorems. Which ones should we use? Well, let's think about the evidence we're bringing. We've got a side, we've got an angle, and we've got another angle. So of our reasons, I've given you a reference sheet that's got all of our reasons. You can print that out and tape it up on right next to your desk at home or on your bedroom wall. These are our 4 reasons. We noticed that we've got 2 angles and a side earlier. So these are the only ones that are talking about 2 angles and a side. Which one of these is right looking at this diagram? All right, here are my 2 angles and my side. So what I need to ask myself is the side between the 2 angles or not? If the side is between the 2 angles, I want to use the reference sheet that has the S between the 2 A's. If it isn't, I want to use the one that does not have the S between the 2 A's. And here, DE would be the side between these 2 angles. And so CD is not between the 2 angles. So that means that my reason here would be AAS. Once again, that's one of those things that if you had the proof kind of up to this point, which at this point is now totally complete. So there were a couple things that were tough about that last part. A couple times when we needed to remember some vocabulary facts. So we needed to remember about alternate interior angles. We needed to remember the reason of vertical angles. And we needed to conclude that the right reason here was AAS and not another reason. So if you had missed any one of those 3 things, you would have gotten 3 points on the proof, which is really awesome because 4 points is the maximum. If you got everything perfectly right, that's the perfect 4 points. So what I hope you've noticed from these videos is that even for a really difficult proof, you can at least figure out how to make a start. I'm going to make a couple more videos like this where we're doing some of these proofs where you're kind of seeing how you can build up from a blank piece of paper to an entire proof step by step, and how at different levels of that of that process, you're going to get a different score on it. So don't feel despondent if you don't see how to get up to 4 points immediately. That's not something, maybe some of you can do that at that point. And if that's so, that's absolutely fabulous. If you are the kind of person who can see how to get 1 point or 2 points at this stage, though, you should be really proud of that achievement. At the same time, you should be thinking about how to move forward. Just like if you're having trouble figuring out how to get that first or second point, I hope these videos are giving you some sense of how to grow like that, because every step up that ladder is an accomplishment and something you should be proud of.